hold on.
Wait, hold the roll.
God. And Michael?
No, she's coming back in a sec, I promise you.
No, look good. And roll it.
Quan Fong 1.
Good, good.
When are you ready to come back?
I think she will be coming back.
She's after coffee, isn't she? I can tell.
Nah, that's the cell culture. Won't take too long.
Thank you for coming on.
Thanks for the chance.
Where do we start? Where did you start? How did you start in science?
Well, it's a long story. It's many years ago now. I've been very fortunate, I think, in terms of education. I was born in Malaysia, and fortunately, my parents were well educated and were very keen on education for myself and my two brothers. So I managed to do some schooling in Malaysia, and because of the situation then, in terms of limitations to academic study, I went to boarding school in England, and then went to medical school in England, and that was very instructive, informative, and really shaped the learning. It was a great culture of learning at that time, and then the ability to get into medicine at the University of London, which was a leading university at the time, really instilled a sense of learning and science, and then galvanized me to do medicine.
Where did you board in the UK? Whereabouts?
I boarded on the Isle of Wight, Bembridge. It's a tiny little village.
Carisbrook.
Yes.
That would have been a culture shock. What's it like going from Malaysia to the Isle of Wight?
It was very cold, I remember that. And food's not great at boarding school, but again, it taught me independence, how to stand on your own feet, how to think, and how to, I guess, get on with people and learn a different way of life. And it was very, I think, instructive, informative to me.
So what was did you get the science bug? Were you intrigued by science, or how did you make the decision? Is it science or medicine in particular?
Well, I liked science. I mean, before my generation, my brothers, one of my brothers is a doctor as well, We didn't have many medical people, but my parents were both educated. My mother was a lecturer, and so that instilled education and science. And then I fell in love with biology and how the body works, and then it went from there. The ability to be able to help people through knowledge.
So you left boarding school and to university.
Mm-hmm.
What did you pick in university?
Well, university did.
Sorry, I'll do the English. What did you read?
What did you read? Well, we went straight into medicine then. In the old days, we don't like nowadays. Many universities you do science and then you do medicine. In the old days, you went straight into medicine. It was a longer course. Our longest holidays was 3 weeks, so it was very intense, but it got you through. So it was medicine from the start, and I was lucky enough to spend a year doing my internship in the UK before coming out here to Australia.
So it's a straight jump, UK.
Australia, yes. And there's no better jump. Australia's a wonderful place. Despite all our complaints, we have one of the best health systems and really one of the best educational systems, I think, that allows people to thrive. We're not as well funded resources as some other countries, but we have opportunity, and it's very encouraging, and I've found it incredibly welcoming.
It's good to hear. A lot of people have said that who've come from overseas, especially Americans. We don't understand it. Yeah, it's really nice. It's really good. Okay, so you did your PhD. What did you do for your PhD?
Well, I did my PhD in bench sciences when the lab here. I did it in the molecular biology of lung cancer. In the old days, when I started, there was wet bench science, but we didn't have the massive changes in technology that have come since. The Human Genome Project, all the biology that's resulted from those discoveries, those landmark discoveries by many scientists around the world, have really changed how we do things, especially in cancer, with genomics underpinning, inherited types of cancer and also treatments of cancer.
Sorry, it seems like, yeah.
Straight.
Excuse me. You're spreading it, Timber. Okay.
Sorry.
Okay, they're all dying.
I fancy.
We shouldn't jest. PhD. The breakthroughs have been astonishing. I mean, I don't think, you tell me, is there a better time to be in medicine than now?
Personally, I don't think so, but every generation will think that. We are very lucky, I think, because of the technology breakthroughs, not just in biology, but also in data science and AI that's coming and challenging all of us. I think we are at a time where the pace of change is very rapid. And that would be one of the challenges, I think, in the future, because we have so many different things now. And believe it or not, for my cancer, the one I'm interested in, lung cancer, over 100 years ago it was a rare disease. But with modern living, smoking, it became so much more common now. It is the biggest cause of cancer deaths around the world. Over 2 million people affected by lung cancer each year. 15,000 Australians develop lung cancer each year. So it would be great to see the end of that, to see it going back to a rare disease. But we have new challenges, things like pollution, climate change, things which are known to be linked to the risk of lung cancer.
This is going to be very interesting for me. So, can you walk me through the changes in the research towards lung cancer? I guess you started in the 80s? Was that
Yes, that's right. Exactly. Yeah, exactly
I was
right.
being sent on jobs up to Cambridge to interview people like you.
Really? No.
The BBC.
Well, in the 80s when we started, it was about, the survival was very poor for lung cancer. Maybe 1 in 6 would survive 5 years on average. Now it's about 1 in 4. So things have changed a heap since then. So that's the amount of change. But in those days, there wasn't much technology, not many effective treatments. There was a lot of stigma and nihilism. In fact, when you were diagnosed with lung cancer, often advanced or spread metastatic. And there was both therapeutic nihilism as well as, stigma attached for patients to come and seek help. So, my early research was trying to work out ways of getting people to medical attention to get some treatments. And there were very few effective treatments then. Surgery was around, radiotherapy, but not much in the way of chemotherapy or systemic therapy that can treat advanced disease. Nowadays, there's a complete revolution. It's incredible that science has been able to contribute to this with immunotherapies, targeted therapies based on mutations within a person's cancer, I'm sure you've heard about. And then now, this year in Australia, we're having a national lung cancer screening program, which will set to change things because we'll be looking to diagnose early lung cancer early enough so it can be cured. And it won't need the systemic treatments that have been developed.
How do you detect early? Now, okay, this is so many questions just popped through my mind. Thanks to your answer. Okay, have you had obviously a eureka moment in your life, and what did that feel like if you have had?
Well, I think it's a eureka moment for many people when low-dose CT came about. When I was training, we mostly had x-rays, and we had CT scans, and they would be printed on x-ray paper. You'd have to hold that up to a light box, and you'd have maybe 6 or 12 images of the whole lung. Now you get several hundred images of the lung and a much lower dose, so much less risky to the person having the scan, and you can see many more things. That's really changed how we look for these lung cancers. We can see tiny spots in the lung, just a few millimeters in size, and some of them will turn out to be cancer. The secret is to try and find out the ones that will become cancer and to offer the person housing those little changes the ability to have curative treatment at the time, be it surgery or radiotherapy, which will cure it. In addition, of course, to prevention. We've made great strides in tobacco control, but there are new challenges coming on board. Air pollution for one, diesel fumes have been counted as another carcinogen for lung cancer, and things we don't even know about. About 1 in 3 women who develop lung cancer have never smoked, 1 in 10 males. So that carcinogen for those people, apart from genetics, family history, and some exposures, we don't know very much about. So unless we do, it's very hard to prevent, unless we know the cause. So that's an active area of research, and I think in the future we'll have to pay more and more attention as smoking rates, hopefully, will keep coming down.
Absolutely. So, what have you done to advance that? I'm going from where we were 20, 30 years ago to today, and you've had the eureka moment, which is, okay, that's discovering it, being able to diagnose that it's there, and then you go figure, is it benign or is it cancerous?
Yes.
That's all about detection.
Detection. So yes, right. I think the eureka moment is a eureka moment for the world rather than for me personally. But that's right. That discovery was the linchpin of early detection. But for us, it's about translating those changes, those discoveries to practice, to actually benefit the person. So these CTs trials started many, many years ago. Started with X-rays, which weren't successful, and the CTs have been over 20 years. They've been in the making, and only now have we seen it now translate to practice. So I think for us and our team, I'm very glad to be part of a team that's helping do some of the early trials in Australia to advance this. But the team, together with the wonderful patients and the participants who volunteered for research, have really contributed to the knowledge that this can be done and it does save lives and can be implemented in our country.
Well, your take must be not unique, but slightly different from most researchers, in as much as you're a clinician as well, so you see it in action as well. Can you talk me through that?
Yeah,
I think
absolutely.
you've got a unique perspective compared to most other researchers who go, Eureka, I've got it, but you don't see it in action. And we were talking to a guy today who was just saying, it never occurred to me that what I'd discovered could save lives until somebody had pointed it out on a personal basis. And he said, I knew it, but I didn't know it, if you know what I mean. So,
Well, I think research and discovery is a team science, obviously. So we'll need people from all walks of life: scientists, nurses, doctors, clinicians. And I guess for clinicians, people like me, it's really grounding to meet the patients, to see the patients, help the patients who have, for us, for instance, this case, lung cancer, and to work through the challenges and to see how it affects them, to try and find out the gaps, the potentials for improvements, and try and implement those, and to try and use the discoveries that others have made and try and implement them in practice, and so that we have the best outcomes for the patients we see. The most rewarding thing is to see, a benefit for the person in front of you.
and the nature of research, I mean, you went into research. What do you love about research? Or do you love research?
I do love research for the potential benefit it brings to people. It brings hope to people. It brings discoveries. It brings new treatments. What I don't like about it is I do. It's not I don't like about it. What is challenging about it? It's hard, long, and a lot of research doesn't get translated at the end of the day because one, it's not as effective as one would think, or it's too difficult to implement. So there's a lot of good research to find those pivotal bits that will be implemented and make a huge difference. So a lot of work under the surface. It's like an iceberg. You see the top bits, which is the good bits, but there's a lot of work from many, many people, and the people who volunteered, the participants, especially the patients who contributed that science, often are not recognized.
Do you want to maybe compress that a little bit? I think you wandered a bit there.
Okay, and how do you shorten?
Just shorten it, but give the same tribute you were giving. But
Okay.
But also, to be fair, we had a lighting problem behind you. The light was going up and
Okay.
down. So
Well, I think one of the challenges for me for research is there's a lot of work to result in things that actually make a difference at the patient level, at the bedside level. So there's a lot of work from scientists along a haul. It takes time. Many discoveries actually do not end up in the clinic. Many biomarkers, for instance, fail because they don't get through past muster and get to a clinical show clinical benefit to the patients. There's also a huge acknowledgement of people who participate in research, the volunteers, the patients who have over many, many years contributed to the science, but often are probably under-recognized.
can research ever fail? I mean, somebody said it's a failure, is it? If you discover, explain the process of research. You come up with a theory and you put it to practice. And if it's negative or whatever, that's still not a failure, is it? It's like
You found some insights, that's right.
Walk me through that if you like.
Well, yeah, I think, a lot of us who work in the field will get ideas from the need from the patient, also from discoveries that's in the literature. So keeping abreast of literature, so other people discover things and you think, how am I going to apply this to our patients? And so you have that, you build a hypothesis, then you got to do the hard bit, which is to seek funding to fund the team, the people who do the work with you, and then complete the work, which is often challenging. For example, the last few years, COVID has slowed everything down, and getting enough people to be in clinical trials to show the benefit, and then publishing the results, and then disseminating that information so they can become translated into daily practice, and then changing policy. Screening, for example, is one of those things. As is mentioned earlier, it's been many, many years since x-rays were used for screening, and then CT scans, and it takes a long, long time to translate into actual benefit so that the community can actually have lives saved from screening.
And the speed of new inventions and new breakthroughs in, I guess, the machine side has been astonishing in the last 15 years. And do you want to talk me through that? Or?
Well, yes, I think,
Because
yeah.
my voice won't appear, so I'm trying to get you.
Oh, right, okay. Well, I think, yes, in the recent times, I think, as you'll see in the lab, there are many machines, and these machines evolve very quickly. We don't have a machine that's perhaps more than 5 years old, because technology is advancing so quickly and so well that it's making things a lot easier to do. In that, however, comes costs. These new machines are more costly, therefore research is more costly, and it's harder to get funding to do the big item research. So in a way, the ACRF funds have been... No,
Could
okay.
you say, no, that's great.
Okay.
Can you refer to it as the Australian Cancer Research
Sure.
Foundation?
So in regards to equipment, this is the unique thing about the Australian Cancer Research Foundation. In the funding of infrastructure and equipment, they have enabled us, our team, to do research that would not be possible. Through the usual competitive grant mechanisms, you can get funding for projects and for people, but for infrastructure, that's very difficult. And so I think this is a huge gap that the Australian Cancer Research Foundation has filled, and it'd be great to have more funds from the Australian Cancer Research Foundation, and thank you to their donors, because this makes a big difference. Getting the newest and the latest, most effective platforms for research means we can find things more quickly, make discoveries, and then translate them to care.
What's the situation of funding in general in Australia? It's obviously not as good as the United States. Disappointing is probably going to be the word, but
Well,
what's the process, just in general?
Okay.
Yeah.
So overall, funding varies. In a way, medical science and health research funding is relatively well funded compared to some other fields. In Australia, we're clearly nowhere as well as funded some other places in the world, but we're not the worst off. So we are very lucky, and we just need to make sure that that continues, and that we try and encourage the next generation who make the next big discoveries. The process for us is to find the idea and then write a hypothesis, a scientific method, and then seek competitive funding. With that competitive funding, that usually allows you to do your main task. Sometimes though, because of the limited resources, that can be limited, so you might have to scale back your work, but that allows you to make the start. And oftentimes it does take several goes to get funding, which is, I guess, one of the challenges of research. It can get quite disappointing if you keep getting rejections and things.
Somebody said that because it is so competitive, some people like to play it safe on what they ask for and don't go for off-the-wall sort of research. And people have also postulated that that's the best research you can do because it's way out there. I have no opinion, you might not either, but is that true?
Well, I think we've seen examples of both incremental research adding to the big picture, as well as disruptive research. Helicobacter, for instance, discovered in Australia, disruptive research with findings that have changed the world.
Well, talk me through that one, please.
Well, Helicobacter was discovered by the Nobel Prize winners from Western Australia, and they were a small team that I think found it difficult to secure funding, but actually did the work themselves and made the discoveries. That was challenging at that time because it was a change to the paradigm.
Okay, but I don't know what it did.
Okay.
So my research, I've been allowed 6 weeks to become an expert in cancer.
Okay.
Of course, I've got everything down.
They found that this bacteria, this Helicobacter organism, was responsible for stomach ulcers.
And there was a breakthrough.
A breakthrough, yes. Before that, people were treating ulcers with surgery, cutting nerves that made the acid in the stomach, thinking the acid was the main cause. But the discovery of the bacteria causing a lot of disease as the pathogenesis made a great change. And
Yes.
so
Yeah.
now, yeah, their treatment's based on eradicating that bacteria now.
That's good.
Mm.
Do you have any heroes in the realm of medical research from the past? Or?
So many, I mean, through the years, I think, that's one of the things. There's so many people. And, in the context for me, I'm driven by the people in my field, obviously. But, all the giants in the past. But so during your training, you see people who've done good work and they mentor you and they support you. Those are the people in your immediate sphere who have influenced me, and they're the drivers, and they may not be big names, but they are important people in my research career.
And the deeper breadths of history. So when you did the history of medicine, was there anything that inspired you? And you can say no, it's all right. I was just wondering.
Well, I think
I started with Hippocrates and all that, but I thought, what's your journey, not mine?
Yes, sure. I mean, Hippocrates, obviously, and I think the pathologists and the biologists, I think, were key for my area, and led to the thinking about DNA, nucleic acids, and therefore to discoveries that have emanated from the Human Genome Project.
Would you mind telling me who these people were and give me a little bit of a, if you can?
Right. Okay. Let me see. On the spot. That's right. That's hard. Let me just see.
And incidentally, we'll be sending you what we've shot and what
Okay.
we cut down. If you don't like it,
Yeah.
we'll
Okay.
redo it. So just be secure.
All right.
If you say something that
Yeah.
you're in safe hands. Yeah.
I'm trying to think because it's that's a tricky one. Okay. Okay. So for DNA, it was Watson and Crick discovered the double helix, and then so many people have increased that knowledge since then, discovering the other forms of nucleic acids and how that works to make the proteins that drive our bodies and undertake our daily functions. So so those would be the people. And then I guess lately it would be the bioinformaticians who've been able to put data together, big chunks of data, be able to come up with results from the massive amounts of data and seeing a clear message and a clear discovery from that data. Because DNA has tens of thousands of genes, and there can be many different changes within those genes.
Well, pathologists, just sort of going back to alchemy in some ways. The search for philosopher's stone. Anyway, I'm not sure. What else would you like to say about your chosen profession?
Well, I think for the chosen research as a whole, but research into lung cancer, I think it would be, just really the chance to pay tribute to the people who've driven the big changes for lung cancer. So people who've worked in tobacco control. That's not a very topical or sexy area to be in, but that's such an important public health message that's really made such a big difference. And then, as I said, the people who've contributed to the research that have led to the discoveries. All the discoveries come from, patients who've contributed to the data or specimens, the cancers that you discover, the mutations in, for example, that have led to specific treatments. Those are, donated by people, and very grateful for those people in making it better for the next generation of people who may be sadly affected by the same cancer.
What is tobacco control? I mean, you said like I should know what it means. Is it just the government making it expensive, or?
That's one of those things. Many different things. Government making it more expensive, public awareness about the dangers and harms of tobacco smoking, the ability to use revenue from tobacco taxes to drive healthcare improvements.
Is it though? I thought it went into general revenue.
Well, we'd like more of it to go into research and healthcare. Yes, I'm not sure what the proportion is, but clearly income that's made by tobacco companies should really go back into fixing the healthcare system. In fact, ideally, we wouldn't have tobacco smoking.
Say that again and make it punchier.
Okay. Ideally, we wouldn't have smoking, because that is, the biggest cause of lung cancer deaths around the world.
I meant the revenue from.
Oh, the revenue. Okay. Okay, so.
There's an election this year, they might follow you.
Okay.
But they're not. The money from tobacco revenue is not going to medicine, it's going to general.
No.
It really should.
Okay.
since they're putting that levy on it.
Yep. Well, it's very sad that this tobacco is still a legal product, but there is tobacco taxes taken from tobacco companies, and it would be ideal if all that went into healthcare, medical research, things to make people better from the effects of tobacco smoking.
And what about diesel? I mean, I remember living in Paddington in Sydney, and once a month I'd hose down the front of my house. It was black with diesel fumes, and then someone said it's carcinogenic. But I thought that was generally known a long time ago.
Well, diesel has been suspected for a long time, but only in the last few years has been classified internationally as a carcinogen. Once that's in place, then people will need to have regulations and processes to control the level of diesel. But absolutely, it's still not very well known, and definitely something we want to work on, because prevention is really the best treatment for any disease.
I don't know where to go with you from there.
It's good to either.
You don't want to delve too far back in the history. Is there anything you want to expand on yourself?
No, I guess really
Any
make sure.
feelings of triumph that you've had in the past?
Oh wow, okay. Well, I think triumph and the reward from research comes from working a team of very talented people, gifted people who are on the same path, have the same ideals and intentions of controlling a particular disease. And for us, is getting rid of lung cancer, making it extinct, and the other benefits and the enjoyment is really, seeing improvements, seeing the ability for changes that have occurred during my lifetime to reach the patient. Many of these new medications, new treatments have come in that time. Screening has come since I started training, so that's very rewarding, and it's also rewarding to be supported. I think big tribute to family. Everyone who does research, or clinicians, anyone in healthcare, you give up a lot of time, and often family does not yet recognize as supporters because they're in the background. But it's impossible for any of us to do what we try to do without the support of our loved ones.
So you are driven by it. It's like what is driving you? There must be an ideal behind it.
Drive is to do research.
What you do.
What we do. Yeah, to make things better.
It's not just research, is it? You're
No.
clinician as well. So it's
Yep.
like,
Well, I think the advantage about a clinician researcher is you get to see the research being translated at the bedside and seeing the benefits for your patients. That's a great reward, and very reassuring that science ultimately, makes a difference in life.
you got a good memory or example of that?
Yeah. Okay. So, for example, for lung cancer, we have targeted therapies, tablets, oral therapies, which target specific mutations in the cancer cell. The cancer DNA becomes mutated, and there are a number of these now discovered. And the first one has been discovered since I started working. That was the EGFR gene mutation, and that's more prominent in female, never smoking people with lung cancer, a particular type of lung cancer, and the benefits are huge. It's a tablet, they don't have to come in for chemotherapy, you have a drip in, and response rates are really good. Toxicity is much less than chemotherapy, and that's an example of how research, the Genome Project, and other scientific discoveries in terms of DNA sequencing and things have resulted in these discoveries that become rapidly translated, and we pay tribute to the pharma companies who have their role, but they do develop therapies which reach the patients.
I meant more on a personal with patients, which is great. What you said was fantastic.
Okay.
But have you had that moment where you put something to train a specific person? You don't need to name them, but have you had that moment with a patient where you go, "This is all worthwhile. This is It's just." Do you know what I mean?
Sure.
Yeah.
Sure. I think for myself, I think the screening model, the trials we did early on when screening wasn't accepted around the world, it was still in the research phase where it wasn't certain whether CT screening would save lives. When we were lucky enough to get funded for some pilot studies in Queensland and in Australia, and internationally, we were able to screen people for lung cancer, discover lung cancers, and many of the early cancers that we found were treated by surgery through our very expert surgical colleagues, and I still see them in the clinic today.
Any individual that sticks in your mind?
Oh, there are several. There are,
Well,
yes.
on a personal note, I wouldn't mind.
Sure.
Yeah.
Well, there's one individual who had several cancers, in fact, and they were discovered and treated. So, having one cancer is bad enough. Sometimes you are unlucky enough to have two cancers. This person had three cancers, and they've been successfully treated. So that speaks to the power of early detection.
And what was your role in that? What was that?
Well, we were part of the screening trial. They were kind enough to enroll in the screening trial that we were fortunate to be part of, and to discover these cancers when they were asymptomatic, had no outward sign of the cancer.
Was that pure luck? That was just...
That's a combination of luck for the person, being the person who found, but also the science was predicated on risk prediction. So from research work that people have done in the past, we know that certain things predict risk for lung cancer. Low socioeconomic class, smoking, of course, age, genetics, family history, pre-existing lung disease, and that was the risk model which was developed by Martin Tanmagi from Canada, that is allowing us to identify people at risk and thus be able to target those people for screening rather than screening every single person, which obviously is very difficult.
Do you foresee a national screening program in the future?
Yeah, we do, and we're very fortunate. So in 2020, Cancer Australia, our peak cancer body, produced a report about lung cancer screening, showing that by that time, evidence had accumulated for it to be seen as a mainstream intervention. And we're very, very, very fortunate in that Australia is one of the few countries in the world now to have a national lung cancer screening program. Ours will start in July, and that has only taken a few years. So we are well ahead of many others, and that will hopefully result in the saving of many hundreds of lives.
How is that going to work?
That's going to work on a national basis. So the Department of Health is working with Cancer Australia and NACCHO, a National Aboriginal Community Controlled Health Organisations, to develop a national program that will reach every Australian that is at risk. That's based on their age and how much they've smoked in the first cut. Obviously, that doesn't cover everyone, and that will allow those people at risk to access screening, which is on the Medicare, so it won't cost them any money, and have that screening, and hopefully any cancers detected will be treated very early and successfully.
So is it like the bowel screening kit that's going out? Was that the intention? Or?
Yes, bowel screening, cervical screening, and breast screening are the other three national programs. And yes, this one will be the first in 20 years, the first national program. This is complex because it's a CT scan, of course, which has to be done at a CT scan provider. And these are big machines and not cheap. But luckily, we have also in the program the ability to use mobile screening. The national program has commissioned a number of mobile trucks which will take to the roads to reach the people in regional and remote Australia who do not have easy access to a fixed CT scanner like they would here in Brisbane.
It's just the lung cancer roadshow. You actually literally take it on the road from Bourke to Broken Hill to wherever.
That is the plan, yes, that's the plan. That the mobile trucks will, I think there are 5 in the initial round to go around the country. To do that, to service the people, to make sure there's no inequity of access and we don't make disparity worse, because unfortunately outcomes for cancer, including lung cancer, is worse in regional and remote areas, and of course in those communities there are higher populations for Aboriginal and Torres Strait Islander people.
Is there genetic proclivity towards lung cancer?
Yes, there is indeed. So a first degree family history increases your risk. And in Taiwan, that many people don't smoke, but they're using family history because that is a marker of risk of lung cancer. And they're finding that effective for their screening program. Different population, different ethnicity, different genetic background, but that may be the future for some types of lung cancer.
Are you a fan of science fiction? Do you read much science fiction?
I used to read Asimov when I was younger.
Oh, you just made me think of Gallagher. I don't know if you ever saw
Gallagher,
the film
yes.
Gallagher.
Yes.
So, are we heading towards that where you can predict based on your bloods when you're born when you're going to die and how you're going to die and what the proclivities are? It's just like that was the central thing in
Yeah.
Gallagher, wasn't it?
Yes,
Like,
yes.
Is that the way we're headed?
Well, I think newborn
In a
screening.
nice way.
Sure. Newborn screening is really effective for many diseases, usually metabolic type diseases where there's damage very early on. But in the future, yes, I guess there's a promise for using genetics in newborn screening to be able to discover and predict the likely course of disease, the onset of disease. And that's important for diseases where there are interventions that are successful. I guess, you've got to balance it out against screening for diseases which may not eventuate, and the person may be told you've got this gene, but they may not get the disease. So there's very complex considerations in using genetics for screening, but that is being proposed using genetic risk scores to help decide the risk of disease and therefore the possibility of intervention and diagnostic testing. The other thing in the future for cancer, I guess, is liquid biomarkers. That's biomarkers in the blood or other body compartments that have the ability to predict the presence of lung cancer. Much of it, at the moment, is based on finding DNA or proteins that are either released by the cancer or as a byproduct of the cancer development. And those are really being researched now, and hopefully will end up as effective tools for us to be able to find these cancers. There's a challenge for early cancers though, because these cancers are small, and being small they don't have as much DNA and they don't release as much DNA as more advanced cancers, and the same for protein biomarkers.
And they're good at hiding.
And they're good at hiding, and they're small and difficult to detect.
How do they hide?
Well, they hide because one, internal organs often don't have pain receptors, so you don't feel the pain unless it triggers some part of the body, for instance the lung. Until it affects the lining of the lung, you won't even feel it. Until a cancer makes someone cough blood, you may not even know it's there. So it's hidden, it's silent, and can grow to very large sizes before a person can feel the symptoms of it.
Hi.
Hello.
Enjoying it? Is there anything you would like to say?
I think you've been very comprehensive.
Have
Yeah. Better than the grant reviewer.
I? Do you got a question there, Andy?
No, good.
I don't know if you are good. A lot of people.
Mediocre.
Okay. You got a question, Joe? See you. Bye.
How do you see the future of with AI, etc.? We already covered that.
No, you
Okay.
look at me when you
Sure.
answer, yeah.
Sure. Well, I think AI is going to change things in a huge way. It's already in some of the things we do. It's already changing practice as a clinician, and I think it's got a huge potential in research. In practice, for example, AI transcriptions happening to allow doctors to spend more time with their patients rather than making notes. It'll summarize the consultation and make the notes. Of course, there are errors and there are issues with AI at the moment that will likely be overcome, but certainly can be managed. I think research is a vast area where there can be huge changes. For instance, for lung cancer, there can be AI used to help the radiologists discover these cancers, see cancers where the human may not even spot them, be the second reader. It may be able to predict survival of someone just by looking at the CT scans, by summarizing all the changes as a result of aging, smoking, any cancers that are there. So there's huge potential. We are just at the start of the journey, I think, for AI. And of course, every tool has harms and benefits. So it's, I guess, important for us to make sure that the benefits outweigh the harms as we go along, especially for healthcare, because it's such a critical element to get things right for our patients that we have the honor of caring for.
Something inspirational. It really annoying me. Okay, I'm just going to try and circle back. Do you have any personal stories? So it's a personal journey with you. And I know you don't want to put yourself above your team. I understand where that's coming from, but it's about how it's affected you. Is there a moment with tears in your eyes or anything? But if you don't, that's fine.
Well, I'm trying to think of one. It's hard because
Well, if you had
research.
one, you'd remember, you
I would remember it,
Yeah.
and it's a team. It truly is a team sport. Research. There's not much these days that you do by yourself. I mean, by yourself you come up with ideas. I think you hear of things from others, and then you think, can I use this to improve the research that I'm doing, to change things, to improve the practice that I'm giving out today, and then you try and identify a novel approach. I think that's to me the beauty of research. It allows you to think, speculate, come up with ideas, but it needs a team, it needs your patients, it needs funders, it needs a whole infrastructure. You can't do research like this out in a tiny little hospital. You just need the whole kit caboodle. And I have to say, we're lucky in Australia that we have many of these elements. Can always be more. Funding is inadequate, but we have a good opportunity, and through work from the Australian Cancer Research Foundation and others, this research will continue, and we will want to do justice to the people who've donated to the Australian Cancer Research Foundation.
What specifically did they do for you?
Right, the Australian Cancer Research Foundation has funded us twice. The first time was to try and develop some breath testing technology for detecting lung cancer. Obviously, even CT scans require a big machine. Breath testing can be done at the bedside. We can take it out to the country. So that was the first grant that they were kind enough to provide us with. And in this grant, they are funding us to undertake mobile CT screening for lung cancer. So the development of a truck which is able to house a CT scanner that will go out to people, and with that truck we will hopefully be able to offer breath testing and blood testing, so we can make use of all the new technologies that are coming online to ensure that we have the best chance of getting the cancers, finding them, diagnosing them, and curing them.
You've intrigued me now. The breath testing, I don't know. Well, this might seem like a silly question. Were dogs behind it? You've got the stories
Yes.
you hear in the dogs,
Yes.
and I'm
You're
joining it.
totally knowledgeable. Breath testing has been around since Roman times. Different smells were associated with different things. Ketones with diabetes, for instance. Dogs have been able to detect cancer, but it's very hard to train up enough dogs to detect cancers for big populations. So many scientists have worked on, chemists, physicists, worked on machines to try and detect the chemicals in breath, and there are many thousands, to be able to find the sensitivity to detect unique breath profiles or chemicals that are associated with cancer. This is still in the research phase. It's a very difficult task. For instance, you can find cancer cells in blood, that's 1 in a million or whatever it is, and the same for breath testing. There might be a chemical, but it'll be 1 part per billion, 1 part per trillion. Very challenging technically to detect, but that doesn't stop researchers. We're going to do our best.
It's exciting though, isn't it?
It is exciting. It is exciting. That's technology, that's science, that's research, all the important things we need to live in a modern world.
With a dog.
With a dog. Yeah, dogs would be great too.
Okay, unless you want to say something else, I think I'm happy.
No, thank you. I think I've exhausted you. I'm happy.
No,
Thank you.
I could go for weeks. Hang on, Steve's got a question.
I was interested, you were saying the personal things that you've got out of it as a clinician.
Mm.
As a researcher.
Yes.
But you've got a story where you've actually got personal relationships as a clinician with patients, and there was something in that that moved you, or that made you think and sort of reevaluate your role as a researcher.
Okay, yeah, I can give you 2 examples. Actually, I share 2 things. Okay, right. So I think as a clinician, we've had the benefit of seeing patients, and we've had patients where cancers have been found, but often they're found at a late stage. And looking back over the times, you can see there may have been opportunities where the cancer could have been detected. We have different technology, newer technology, different ways of doing things, and that really strikes a chord because you look back and you think, this person, you know, if we had this then, we could have done better. Their lives might have been saved, and instead of a very advanced cancer, when the hope is to treat the symptoms. I guess the other personal inspiration for me is that I think lung cancer is so common that we're all affected. We all, I suspect, know someone or have a relative with lung cancer. And I personally have an aunt who had lung cancer who never smoked. And she was in Malaysia, of Chinese extraction, therefore genetics likely to play a role. And that's sort of also given us the impetus to do what we do. We have a large lung bank here at the Prince Charles Hospital where we collect samples and undertake genetic and genomic research. We share those samples around the world with other researchers. We've shared it with the Cancer Genome Atlas Project. We're collaborating with the NIH, the United States NIH, National Institutes of Health, and we're just about to start collaborating with the Crick Institute in London for some of these studies.
Really quick. Don't know how the NIH in the States are going to go with Trump at the moment.
Very
That's
scary.
Go there.
Yes.
By the time this comes out, that will be resolved itself anyway.
Hopefully so. Hopefully so.
That was great. Thank you.
No, thank you very much.
Thank you.
Appreciate that.
Very good.
Is that alright? So,
I think
Yeah.
you're great. I think
You're-
he speaks very fast. I don't think you speak that fast. I followed you.
do you want me to slow down?
No, I think you were fine.
Thank you.
Andrew, you're the one listening.
No, it was excellent.
No, it's very,
Yeah.
very nice.
Oh, thank you. Oh.
Take the rest of the day off.
30 seconds. No more than 30 seconds, please. The other people are
We don't-
much
we
more
don't-
interesting. You're not going to edit it?
No,
You'll edit it. Keep me down to that bit. Just give a few sound bites will be plenty.
We're not the soundbite sort of people. We're not the news, and we're not after a 30-second or 90-second
Oh
story.
dear. How long is this going to be? An
Well,
hour?
it might be a series.
What?
Yeah. Well,
Well, there's a lot of material on a series
there?
of
Yeah.
hours. It's also different.
the
Ah,
minimum
yeah.
is going to be 90 minutes.
90 minutes?
People,
Yeah.
The minimum will be 90 minutes
Right.
feature for theatre.
Yes.
But we feel the way it's going is probably going to...
Well, I think it's amazing. There's so many different researchers, different types of research. I mean, that is one of the benefits of science and our current generation. There's a variety of work that's being done, all on different fronts and all critically important because you never know when the next big discovery is going to be.
Well, that was the thing. We didn't just want to do cancer. It's like that's
Mm.
why it needs to be medical research and the philosophy behind research in itself, which is it's reasonably new, really, isn't it?
I think large-scale research is reasonably new. I think in the old days, from Hippocrates onwards, there have been people doing research, and officers, people who have huge intellects and the ability to do that research on their own. But in this day and age, I think the world's evolved that it supports a broad range of research, team research as well as individual excellence, and I think that speaks very well to the fact that discoveries are made all the time in different places you wouldn't expect, and that's inspirational for people to have the chance to make a difference.
And it's optimistic. I mean, there's so much around now. Oh God, it's so pessimistic with so many things. And I grew up, and you would have grown up in the same era, the space race and all that, when anything seemed possible.
Mm.
And it was an optimistic time, and it's sort of like, I don't despair, but look around and go, ooh, it's the end of the world as we know it. But it's like, no, you should be looking forward to a wonderful...
Absolutely. I think, there are things going to happen that we can't even dream of. Immunotherapies were never a possibility when I started training. These targeted therapies, tablets for lung cancer, never even envisaged. It was all very toxic chemotherapy, very difficult for the patient, very difficult to give because of the side effects. Heartbreaking. And now things have changed so much. We just need to keep optimistic and keep going.
Thank you. You cut there, thank you.
Thanks a lot.
Thank you, sir.
No, thank you very much.